So we shall quickly look at the concluding parts of qualitative analysis that was started before we had a short break. Now today we are going to be looking at the cations and anions. Cations are positively charged ions like sodium, calcium, aluminum, lead, zinc. Okay, and anion are negatively charged ion. Okay, like NO3 minus, CO3 2 minus, SO4 2 minus, and so we are going to see how we can identify both cations and anions. Cation can be identified by two major reagents, sodium hydroxide and aqueous ammonia, and as we further explain in details. So we look at identification of cation and anion properly. What are cations and what are anions? Cations are positively charged ions. Example include potassium, sodium ion, potassium ion, calcium ion, zinc ion, aluminum ion, lead ion, etc. All the ions that have positively charged, they are cations. They are essentially metals. While anions are negatively charged ions. Okay, they may be group of ions. Okay, they include CO3 2 minus carbonate 4 ion. We have triosonitrate 5 ion. We have tetrasulfate 6 ion, trisulfate 4 ion, and so on and so forth. So that is a simple definition of anions and cations. So now I want to look at how you can identify them, because in your WAEC exam you'll be asked to carry out an experiment to identify this ion using two reagents. For cations, we use two reagents. We use sodium hydroxide and we use aqueous ammonia. So, and they have different behavior in these two substances. So let us see how we can identify cations using sodium hydroxide. So the solution, first one, solution of sample. The solution of unknown sample, you will be given a salt, so you put in the test tube, dissolve it in water, and you will have to have sodium hydroxide to heat in drops. So when you add it in drops and you see white under observation, you see white gelatinous precipitate, and you add in excess, the precipitate then soluble in excess sodium hydroxide, that confirms that zinc 2 plus may be present, lead 2 plus may be present, or aluminum 3 plus are present. These are the cations that can be present in this. So this particular test is not specific. Okay, these three ions behave in sodium hydroxide in drops and in excess. So second one is when you have solution of sample, sodium hydroxide is the unknown solution of sample in drops, and you see dirty white precipitate, and when you add in excess and the precipitate is insoluble in excess sodium hydroxide, you see it in the test tube that the precipitate is insoluble in excess sodium hydroxide. That confirms the presence of calcium ion. Okay. Third one, solution of unknown sample plus sodium hydroxide in drops. If you see a light or pale blue precipitate in drop and excess precipitate is insoluble in excess, that confirms the presence of what? Copper 2 plus ion. So the transition methods will be identified by their colors. Okay, unlike the zinc, lead, aluminum, and calcium, that they are white precipitate. For the transition element, they are very easier to identify because of their color. Copper is blue, iron is green, iron 2 is green, iron 3 is brown. Okay, so lead is black. So with this color, we'll be able to say that this is a particular anion, cation that is present. So for the copper 2 plus, it is pale blue, which is precipitate insoluble in excess sodium hydroxide. So the next one, sodium hydroxide is added to the solution of unknown sample in drops. If the solution form dark green precipitate and it is insoluble in excess sodium hydroxide, it confirms that iron 2 plus are present. Okay, green iron 2 plus are present. Another one, next one is that when you have sodium hydroxide to the solution of unknown sample in drops, I see a reddish brown precipitate, and when you have sodium hydroxide in excess and the precipitate is insoluble in excess, That confirms that iron 3 plus are present. Next, when sodium hydroxide is added to solution of unknown sample in drops and you see a brown or black precipitate, and the precipitate is insoluble in excess sodium hydroxide, it confirms that silver are present. So solution of sample, next one, the last one is solution of sample plus sodium hydroxide in drops and if there is no precipitate or if there is no feasible reaction, but on warming the solution, a gas with choking or irritating smell which turn red litmus paper blue is given off, that confirms that this gas is ammonia and the ammonia is coming from ammonium salts. So that is how to identify cations using sodium hydroxide. So let's say you can identify cations using aqueous ammonia, because I told you from the beginning that you can identify cations using two reagents, sodium hydroxide and aqueous ammonia. We have seen for sodium hydroxide. Let us now see how you can identify cations using aqueous ammonia. So we have test, observation, and inference. Okay, test is what you carry out. Observation is what you see when you are carrying out the experiment, and the inference is what you suspect that it is present. So in this, aqueous ammonia is added to the solution of unknown sample in drops, and a white gelatinous precipitate is formed, which is insoluble in excess aqueous ammonia. That confirms that lead or aluminum are present. So that means that you will be able to remove zinc from them, because both of lead and aluminum, they form a gelatinous precipitate which is insoluble in excess aqueous ammonia. So the next one is sodium aqueous ammonia is added to the solution of unknown sample in drops, and white gelatinous precipitate is formed. In next, precipitate soluble. In this case, precipitate is soluble. That confirms zinc is present. Okay, zinc ions are present. It is only zinc ions that are soluble in excess aqueous ammonia. Okay, so we can use aqueous ammonia to differentiate between lead, aluminum, and zinc. Both of the three of them behave the same way with sodium hydroxide, but with aqueous ammonia is only zinc that is soluble in aqueous ammonia. So the other one behave the same thing as they behave with sodium hydroxide. Okay, when you add aqueous ammonia to the unknown sample in drop and excess, no precipitate, turbidity due to CO3 in the reagent, and it confirms that calcium ions are present. Aqueous ammonia is added to the unknown sample in drop and excess, light blue. When you see light blue or blue precipitate, it shows that, and precipitate is soluble, giving a deep blue solution. That confirms that copper 2 plus are present. Next is aqueous ammonia is added to solution of unknown sample in drop and excess. If a dark green is formed, and the precipitate is insoluble in excess aqueous ammonia, it confirms the presence of iron 2 plus. If it is iron 3 plus, it will be reddish brown precipitate. If it is silver, it will also be black precipitate. So they behave the same way with that of sodium hydroxide. And for the last one, you have aqueous ammonia to the solution of non-sample drop and excess, and there is no precipitate, no visible reaction. It confirms that ammonia gas is evolved, and this ammonia gas is coming from one ammonium ion salt present. So these are to identify cations using the two reagents, sodium hydroxide and aqueous ammonia. So let us now see how you can identify confirmatory test for cations. If you look at aluminum and lead, their reaction in sodium hydroxide and aqueous ammonia is similar. So we can differentiate them. That is their confirmatory test. But let's see that of calcium first. When a aqueous solution of unknown sulfide is added to ammonium triacarbonate 4, okay, or ammonium oxalate, and a white precipitate is formed, it confirms that calcium is present. That is the confirmatory test for calcium. This particular test for calcium came out in Y 2016. You check your past question, you see where they are asked to identify calcium ion. So that of zinc, lead, and aluminum, it always come out every year, so there's no doubt about it. So an liquid solution is direct to ammonia solution and ammonium chloride solution. So we use these two reagents, ammonia solution and ammonium chloride solution, is added to the unknown substance, and if a white precipitate is formed, it confirms that aluminum is confirmed, aluminum is present. So this is how to confirm aluminum, because this reaction, lead cannot form white precipitate with this reagent. So for lead, if aqueous solution, potassium heptazodichromate 6 is added to the unknown solution or potassium iodide solution, I see a yellow precipitate, it confirms that lead 2 plus are present. So this is the confirmatory test for both aluminum and lead. Okay, so that is that. Let us now quickly look at the test for anions. They are negatively charged ions. Okay, so let's see how you can identify chlorine ion. So the unknown source solution, we have 7 trinitrate solution to it, and a white precipitate is formed. It confirmed that it showed that chloride ion is present. But if you add dilute HNO3 in drops to the solution and in excess, plus ammonium hydroxide in excess, and a white precipitate dissolve, this is a confirmatory test that shows that chlorine is present. So the second one is when you add dilute HCl or conc H2SO4 to the unknown source solution, and there's a liberation of a colorless gas which turns damp blue litmus paper red and turns lime water milky. So a gas that turns lime water milky, whenever you see something like that, is CO2, carbon dioxide, and this CO2 may be coming from trioxocarbonate 4 or hydrogen trioxocarbonate 4. So you confirm that it's either trioxocarbonate 4, CO3 2 minus, or HCO3 minus are present. Okay, so the next one is when you add barium chloride solution to the unknown source solution and plus few drops of HCl. Now, if a white precipitate is formed which does not dissolve in excess of HCl, that confirms that SO4 2 minus are present. But if a white precipitate is formed but soluble in excess HCl, it confirms that SO3 2 minus are present. So these are the differentiate between tetrahydrosurface 6 ion and trihydrosurface 4 ion. So the tetrahydrosurface 6 ion is insoluble in excess HCl, while trihydrosurface 4 ion is soluble in excess HCl. So that is that. Now next one is when you add acidified potassium heptazodichromate 6 to the unknown source solution, and the orange color of the reagent turns green, it confirms that SO3 2 minus is present. So that is how to confirm SO3 2 minus. Next one is that when you add freshly prepared iron 2 sulfate to the unknown source solution plus conc H2SO4 slowly down the side of the test tube and hence in a slanting position, and after that you observe that a brown ring is formed at the junction of the two layers, it confirms that NO3 minus confirmed. The brown ring is due to the formation of FeSO4.NO. So this is a brown ring test, and this brown ring test is used to identify trinitrate salt. So this is where we are going to stop for today, and we're going to continue when you resume properly on Monday. Thank you.